What is up, everybody? Thank you so much for tuning in to another episode of the Anti-Gravity Group podcast. My name is Braden Carlson.
My name is Taylor.
My name is Shane, or as you might know me, Postart.
And it is another guest episode day because we recently discussed on the podcast the big news that Tripoli now allows bipropellant liquid motors. And we thought maybe we should get someone involved that knows what they're talking about. So, Austin, please tell the people who you are and what you do.
Hey, yeah, I'm Austin Sennott. I am one of the two members of HalfCat Rocketry. I, along with my friend Charles Sharp, we make liquid rocket motors in our garage. And we publish all information on our website.
Yeah, I was going to say, you can go ahead and plug the website up front. There's going to be a lot of references to it, I'm sure, throughout this episode. But
yeah, our website is, of course, halfcatrocketry.com. It's pretty easy to find because the name is a little bit unique. And at this point, we're probably almost as well known for Mojave Sphinx, which is one of our rockets. So you can find it by looking up Mojave Sphinx as well.
Yeah, I definitely would have plugged the website on my own, and I was like 95% confident that it was just halfcatrocketry.com, but I was not willing to say something that was incorrect. So thank you for saving me on that one. But yeah, so like you said, Mojave Sphinx, it flew at Balls last year. It flew at Airfest this year. Shane and I have the privilege of getting to see when you and Charles are kind of going hard mode with that rocket. Because I believe I've seen you in one day at Far Flight at least 3 times.
Yeah, so we've had a couple days at Far, multiple days at Far where we've done several flights. There have been days we've done multiple static fires and flights. There was a day, it was beginning of January last year, actually the very first Far launch of the year. We did 3 Mojave Sphinx flights in a day, and then later in the year we did 4 in a day, and then just this past Saturday we did 3 on Saturday at RRS.
That's awesome. Yeah, I was gonna say it's always a fascination to people when I post anything about a liquid because I'm pretty hobby oriented in terms of my channel production, so it's super exotic to see anything that's not just APCP. So that again kind of brings us back to why you're here. But first, Matt is arriving late, so we have to berate him just a little bit, I think.
Please do.
Was it HOA night, Matt?
No, we've got that squared away. I was actually working on something that might be rocketry related. So,
all right. Well, I guess people will have to wait to hear about that in the next episode.
Yeah.
We have a guest.
I
thank you for disrupting, Matt.
I apologize in advance, Mr. Sennott.
Already got his name wrong.
I'm sorry. I'm a mess.
It's really funny is you completely were disruptive, but that was all on me.
That's fine. Thank you.
So you've worked fairly closely with the Tripoli board of directors and being allowed to fly liquid stuff at Balls and then Airfest. So I imagine in the background you had a not insubstantial amount of input on outlining the rules for liquid motors being allowed at Tripoli launches. So it's
yeah. So this kind of started last year. So whenever I talk about us doing stuff, I'm really talking about me and Charles. So even though he's not here, just pretend that I'm also speaking on his behalf because we are the two halves of the HalfCat. So last year, it was, I think in June, we submitted a proposal to launch Mojave Sphinx at Balls 32. And Patrick Morrison, aka Turbulent Sphere, and Ryan Callahan, aka Keg Rocket, also put in proposals. And of course, those were accepted by Tripoli for Balls 32. At that time, they really had no idea what that was, so we went through that whole thing. And then again, this year at Airfest, we did the same. And over the course of that time, we were sort of educating the Tripoli board on what these were. And over the course of this year, Bob Brown, the president, as well as some other members of the board, kind of approached us asking us, like, what would a liquid safety code look like, if these were to be included under the insurance. So we put together kind of a proposed, modification to the safety code of what we would say, this is what a liquid safety code look like in addition to what's there currently. And so they took that, And then we did the Airfest demo. And then following that, um, some board members kind of like reached out to us and like, here's a draft of the safety code that we're going to put forward for vote by the board. And so we did some edits on that, sent back our proposed edits. We'll have to wait to see what the final safety code looks like, but it looks like they did take some, maybe a majority of our edits to their safety code. So yeah, there was quite a bit of back and forth on the back end there. We tried to come at it from the perspective of like, how do we make these safer for everyone? How do we make this a little more like controlled and kind of almost limit the scope of what's allowed so that people don't start showing up at Tripoli launches with things that are just blatantly not appropriate there.
Yeah, get some hypergalls out of the Gene dry lake bed. Okay, so I actually think that's a really good segue and a place to start. Basically, what we're going to ask of you here is explain like I'm five breakdown on starting with building a liquid. But I do want to shout out real quick, HalfCatRocketry.com/resources. Like you said, you guys both, you publish everything that you're doing, right? And that includes designs of pretty much everything, or not pretty much everything, I suppose, right? But I do think personnel safety being on this resources page is a really good place to start. So coming from the world of maybe not even people who mix their own solid propellant, but just people who interact with solid propellant, what kind of offshoots for safety specializing in liquid production would you say are things that need to come to mind of people that are interested in getting involved?
Yeah, and everything I'm about to say is on that safety page. It's also embedded in the Mojave Sphinx guidebook. I'd say there's a few key differences to liquids versus solids. It's kind of sitting there right in the name. We kind of take it for granted, like, oh, liquid, solid, but it kind of lays out what's like your big differences in failure modes and safety hazards are going to be. With solids, obviously, all the things that you guys understand of like grains can explode, they can catch fire if you have a static shock, and all that stuff. And I guess I'll take it through hybrids real quick because that's something, it's kind of a transitional thing that I think some flyers are more familiar with. And it's where a lot of the safety aspect actually comes from. For one is safety around nitrous oxide. Nitrous oxide is technically not an oxidizer in and of itself. It decomposes to oxygen and nitrogen. And in the process of that decomposition, it releases a lot of energy. This infamously, explodes quite violently if it all decomposes. So you really have to kind of treat it with a lot of respect. That means like never being around it when it's outside of its bottle. Because like you don't expect that it's going to decompose, but it could at any time. So you just have to stay far away from it. You have to, whenever nitrous is like let out of the bottle, you have to treat it like it's an active motor firing, and as you would for a solid, be far away from it. So there's a lot to talk about in there, and again, it's all in the safety section. But it's mainly related to mitigating the danger through distance. I like to say that like you can do all the oxidizer safety and like compatible materials you want, but any kind of amateur rocket is never going to be safe enough to stand next to, and nitrous oxide is in it. So that's why that the safety distance matters. And as far as the liquid fuel goes, it's, people kind of picture like gasoline as liquid rocket fuel, but to be honest, gasoline is actually much more hazardous than most liquid fuels we would use. That was actually one thing I think in the draft safety code proposal that we had seen. It did make mention of gasoline. Don't quote me on that because I don't remember specifically offhand. But we did specifically tell them like, hey, no gasoline, or at least pure gasoline. And yeah, the main danger with liquid fuels is that, like, obviously the liquid fuel can catch fire. So if there's like a spill, you want to be aware. You don't want to have heat or ignition sources nearby, because vapors could potentially catch fire. Most of the fuels we use are like alcohols or gas blends that are mostly alcohol, like E85, so that the vapors are less volatile. So you have to be aware of like those kinds of spills, like getting stuff on your hands. And yeah, aside from that, it's really actually quite inert. It's one of the neat things about the liquid fuels is that they don't contain an oxidizer like solid propellant, so there isn't the risk of like massive self deflagration as you have with that. Um, yeah, it's kind of just like you're being aware of handling, mopping up spills, staying away from nitrous when it's out of its bottle, and then all the other usual things you deal with rockets, right? Like no open flames. Um, don't arm your igniters until as late as you can, that kind of thing.
Yeah, that's it's interesting to hear that coming from the world of us also being car people. And I'm just like thinking about all the like drag strips where they're just like purging nitrous straight out the hood with 80 people standing next to it. So that's
Yeah,
fascinating to hear.
I have a lot of thoughts on the safety at car events, but yeah, that's something we can talk about on a different podcast.
Right. Yeah, that's crazy. And I think probably the misnomer of the gasoline thing probably comes from you guys running E85, right? Because you get E85 at a gas station, and it's not like again, we're car people, so we're very familiar with E85. But outside of being like a car person, it's not like firsthand knowledge that it's really that different from a standard like unleaded gas. So that is interesting to see because I did know I pulled up the announcement. It says mixtures containing at least 70% isopropanol or ethanol by volume are allowed. These mixtures may include other hydrocarbons, dissolved liquids, gasoline, or water. So provided they are not hypergolic or pyrophoric. But yeah, so that was the gasoline still being included as a potential mixture is interesting. It seems probably like not really enough juice for the squeeze. But to give you an idea of how little we know about liquids here, the last time we brought this up, I had everybody guessing what the acceptable fuels were, and Taylor said liquid oxygen, and none of us were quick enough to suggest that that's not even a fuel. So we're all about on the same level playing field of zero knowledge at this point. And everything I know about liquids has basically come from watching you and Charles fire them at FAR for the past couple years. So safety, I felt like was important to highlight up front. But if you could go down to as base level as you can, without driving yourself insane. But we know a solid motor. This is a propellant grain. This is a liner. This is a nozzle. Can you kind of break down the anatomy of a liquid rocket motor or engine if you want? That's a great another argument for another time. But for people who don't have any clue what's going on here.
Yeah, and I will refer to them as motors. I have my thoughts on the definition, so I basically trained myself to say motor on these things. But yeah, for a liquid fueled motor, liquid bipropellant motor, because I suppose you could have some reverse hybrid insanity. For a liquid bipropellant motor, you've got like three major sections. There's the propellant tank, the fluid system, and the thrust chamber. The propellant tank is, in my opinion, the most important aspect of it. Like that's the one kind of big thing that will like define the architecture of your whole liquid motor. And I'm going to be talking on a specific subset actually because it's what the Tripoli code talks about, and that is what people generally refer to as HalfCat style liquid motors, which is there's just like a sliding piston in it, and we'll talk about that in a second. So in the propellant tank, that's where you're going to store your liquid oxidizer, or just liquid nitrous, and liquid fuel. So in HalfCat style liquid motors, you'll have like some big casing, and even further, there's kind of multiple styles. There's concentric tank, stack tanks, but essentially, in very broad terms, you have a big casing with a part that fills with liquid nitrous oxide, and then a sliding piston that's sealed with a couple O-rings. And on the other side of that, you have your liquid fuel. And that's kind of what makes a HalfCat style motor. And then you'll have outlets on both of those parts of the tank that each feed to a propellant valve. So you have an oxidizer valve, you have a fuel valve. Sometimes they're combined into like one piece if they're like one of these Discord guys that has like a really sleek, like tightly packaged one. But you'll have a valve for each, and then that will then connect to the thrust chamber where you'll have an injector that's like at the top of your combustion chamber, and then you'll have a nozzle. And there's a lot of ways you can go with those different parts, but generally it kind of goes down to those three. I would say maybe the most common or like practical style is like the Mojave Sphinx style. So again, I'll just reference that. Go see the book if you want to see like the basic version of that.
Cool. Yeah. And, like you said, all of your resources are available on your website. And I think now is a good time to throw it to the Mojave Sphinx guidebook, HCR 5100, it's available as a paperback, but is the download free?
Yes, the download is free, and the paperback is only whatever it costs to print.
Cool. Yeah, and that's a really helpful thing because we get a little bit of flack on this podcast for focusing on things that are very visual and when it's just a topic of discussion. So I just want to give a special shout out to all the audio only listeners to know that we also are completely in the dark. We're not looking at anything. So if you're having as much trouble imagining what's going on as we are, then great news. The book is free to download. You can check out the HalfCatRocketry.com website for visual references on all of the discussions in today's episode. But yeah, so I do want to talk about Mojave Sphinx a little bit because it's the first time I met you guys, I was talking to you about the rocket. And I was kind of like, what's going on here? And I don't remember if it was you or Charles, but you were like, it was made literally out of garbage. Like, I'm not kidding. This is stuff we pulled out of the trash. So can you speak to that rocket's design a little bit? Because I know the first thing a lot of people want to know when they hear that now a biprop is a feasible thing at a Tripoli launch. You can do this. How much is this going to cost? And if I'm not mistaken, it seems like the point of that rocket was to do it as cost effectively as possible to some extent.
Yeah, Mojave Sphinx. Like, I don't remember specifically when we first came up with the idea for that. It was sometime in the summer of 2023. But it was kind of like the next step in the evolution of rockets because we had just done full cat and 3-cat 8, which were like our 4th generation rockets. They have pneumatic half-cat valves, kind of a pain to work with, but they're really lightweight. And then Mojave Sphinx kind of came about as like, okay, let's like reframe our thoughts here and be like, what's the easiest way to do one of our liquid rockets? And that was like, well, we've got these neat servo actuated ball valves. We've been using our GSE forever. And we even told some college teams like, hey, if you want easy, just put it in there. And we're like, well, why don't we just do that? So that's where Mojave Sphinx was like born, was from that idea. And kind of from the beginning and all the way through its execution, it was like, what is the easiest, like simplest, like most accessible version of our architecture? And over time, Mojave Sphinx like just kept evolving to be that exactly. And everything was like, it was driven by two things, like ease of use and cost to produce. So, for example, some steps on the way looked like eliminating machined parts. So that's like one reason we got rid of the half-cat valves, is like that's, each valve has a body and a little internal piston. It's 4 parts total we can get rid of. And we, for ease of use, we used to have high pressure nylon push connect lines for like our propellant lines. We turn those into 37-degree flare braided flex hoses because it's just way easier to use, even if it's a little more expensive. And so we eventually found like this nice balance of cost versus simplicity. And like operability. That's how we got to like the 20-minute turnaround time that we eventually did. And that's also why the airframe part of it is like actually garbage. On several occasions, we did use either shipping tubes that's other stuff came in, or just tubes that had at one point or another been in a trash can to fabricate airframes. Especially because the lower airframe tube, Mojave Sphinx, is like notoriously low life. Like we consider it single use. It just is so often like ripped or something. Yeah, I mean you can upgrade the tubes if you care to, but the default one is like these shipping tubes from McMaster and our 3D printed couplers and nose cones, which are good quality. I'll say they have threaded rods in them, so they're really just 4 threaded rods in a trench coat more than a 3D print. But yeah, people they're kind of appalled by the quality of some of the parts. I think maybe like the $25 Amazon tent tarp parachute. That's maybe one of the more questionable things in it. Especially if people have like experience with like big sport rockets, they're like, "Why are you doing this?" And we're like, "Well, there's a couple of reasons. One is make it cheaper for people, so you can get into liquid rockets, and two, like we're not here to give you the best liquid rocket. We're here to give you a starting point, and if you so care to go improve from trash, that's kind of the point."
It's not the liquid rocket we want. It's the one we all need.
Yeah.
When I found out you guys were doing the tarp, that made me so happy, because one of my few like halfway viral rocket moments on Twitter when I was using that app regularly was a picture at the Lucerne Dry Lake bed of like one of those Walmart 10x10 canopies that cost $40, and I was holding the tie down straps and it was filled up like a parachute. And I was like, someone's got to do this. It will work for sure. You just can't open it too fast. But so I know we said that it was about equivalent to M Impulse at Airfest. Is that correct?
Yeah, the ones at Airfest were actually a different configuration than the standard that's in the book. They're an upgraded one. The base Mojave Sphinx is like a baby M or big L, depending on the day. And the ones at Airfest were like a mid-range M.
Okay, cool. And I was glad to hear you bring up, it being born of not just cost effectiveness, but ease of assembly. So that was one of my questions that I think a lot of people are going to have here too, is like what level of complexity in construction are you kind of looking at as a baseline to some extent for getting into this? Do you need a lathe, or do you need somebody who knows how to use a lathe, or is it all just McMaster parts?
A lot of it is McMaster. There are machine components in it. I don't know how many offhand that require a lathe and either a mill or a drill press. So, if you have somebody that knows how to use those or has access to one, they're very simple to make. You can use as like an intro to machine tools project, or you can order them from somewhere like Xometry or Sennott or where have you, wherever your favorite online machining service is. Not too high of a cost. Yeah, and then beyond that, it's just like basic hand tools, like a hand drill, wrenches, stuff like that. I think our assembly instructions like say what you should use at each step.
Okay, and sort of going back to the impulse size, and if you kind of come at it from a Tripoli or NAR angle, do you think that this is the scale that someone should start working at, or is there like a smaller starting point? Because I mean, in the world of making a solid motor, like generally starting something bigger is a little bit easier just because it's less finicky in general. But I think some people might be a little scared of that impulse level. Granted, for it to be a research flight or Tripoli launch, you're going to have to be level 2 anyway. So I guess flying a high impulse L isn't that out of the question. But sorry, I'm rambling on the question. But
yeah, that's actually a really fascinating question to explore, because it's exactly like you said. Sort of the typical mindset is, especially for solid motors, is like they're almost infinitely scalable, where it's like, oh, you want to start with something easier, but you go smaller, like you can do a 38 millimeter or 24 or even an 18 millimeter or something like that, because the general principles are the same. This is really true of any rocket motor, but you can just machine a smaller bulkhead and a smaller nozzle. The same is not exactly true of liquids. And I had some amusement recently from some comments on the Tripoli announcement where somebody's like, well, I think we should limit these to G class, until some criteria they set. And Patrick Morrison had a laugh at that because he's like, do you know how hard that is? The trouble
Right.
with making small liquids is that you have to machine small holes and get very small fittings and small tubes because liquids have to go places. So that gets really challenging below the I or H or G, somewhere around there. It starts getting really difficult. Patrick has his tiny liquid, which is like an E class, and it's just it is a work of art for that design to work. So back to the original question, I guess, is Mojave Sphinx the right place to start? I think if you're working in a team, if you've got 2 or more people, it's definitely, I would say, the right way to go. We sized the rocket so that you would end up with something that's cool and kind of impressive. If you're working on this for a few months, you get to the end and it's well, we've got something cool to show for it. Sort of with a mind towards college teams, but there's plenty of other people besides college teams that have made them, and it's kind of this is a cool rocket in the end. And also because going down in size for that architecture doesn't afford you many savings. We have a 3-inch version, boron links, which it's basically just a 3-inch Mojave Sphinx, and the BOM cost is not that much lower, and it's more of a pain to deal with because it's harder to fit your hands in to work on stuff in the valves. Now that said, there are other ways to do these types of rockets that can make them scale down, and I guess I'll mention something we haven't talked about publicly, but I guess in a couple months we'll probably be showing off more. We're kind of working on a bit of a smaller liquid rocket that's maybe even more accessible than Mojave Sphinx in the near future, given the Tripoli announcement. So maybe stay tuned for that. But for right now, I would say, if you're trying to get into liquid rockets, Mojave Sphinx is probably your good jumping off point, just for the ease.
Okay, cool. I'm curious if anybody, Matt, Shane, Taylor, any questions that have arisen yet?
I think I'm primarily curious about the controller for that. What all do you guys use to control the valves and the solenoid, or the servo actuated valves?
So Mojave Sphinx its valves are, like you said, it's servo actuated ball valves. So they're 3-pin connection, and there's actually no control on board the rockets, and this has been the case across all of our rockets, and will probably continue to be the case going forward in all of our future rockets, with the exceptions of maybe some special cases. All the controls are actually ground side. We have this red toolbox that the guide calls for to make. We also have some other mini GSEs that we use, but essentially, we have this RC aircraft controller because it has a good wireless connection. It's got all the stuff built in already. We know it's reliable. We know it's going to work. It's got you can set the fail safes. It's got automatic digital frequency hopping, so it's robust to interference. And the way we do that is we hook up the rocket to the ground station, and the ground station will do its fill through its valve. And then when we go to launch the rocket, we have 2 switches. So I just push both my switches at the same time, and one of them is firing the igniter through a relay, and the other is opening the propellant valves, and do those together, and the rocket takes off, and then it unplugs itself. So it's very, very compact, robust system.
Yeah. That's cool.
Great job teeing that up, Matt. That was actually going to be my next topic of discussion, was the GSE outside of the rocket that's necessary. So That was perfectly timed. Shane, Taylor, you guys got anything?
What does, in maybe a condensed fashion, if it's a lot of steps, but what does prep look like when you're getting ready to fly it or refly the setup?
There's only a few things you have to do for the rocket. For one, you have to repack the parachutes. That's standard for any high power rocket, so I won't bore you with those details. I'm sure you know more about it than I do. For the propulsion system, really all you have to do is you take out the forward bulkhead of Mojave Sphinx, you push the piston back down to its set depth. We use a PVC pipe that's marked with the depth we need, and then pour in your liquid fuel, put that forward bulkhead back on, close your valve, hook up the fuel hose again, reattach the servo wire to the servo valve. Then you load a new igniter. So Mojave Sphinx has a cartridge igniter, so you take that off, take out the old motor, get a new Estes motor, drill out the throat of it, so you've just got exposed black powder grain, then drill out. Well, you can drill out the ejection charge, and I always do, but you don't have to. Just creates a little chuff in the chamber. We use an Estes A3 or sometimes an A10 if we run out of A3s. So you just pop that back in your igniter cartridge, close up the fittings, put it back on the chamber, and like snake the wire through the hole and pull it out. And then you're good to go. Just rack it again and hook up all your connections.
And I think piggybacking on that, once it's on the pad, what is, for those unfamiliar, what is the process of going from starting a fill to launching the rocket look like? Because, obviously there's that filling step that you don't see traditionally at a hobby rocket launch. So it's always fascinating to see people's first reactions to that.
Yeah, we use a sensible static vent size. Just real quick sidebar, a static vent is a thing in the tank that ensures that you can't trap pressure in there. It's just a tiny little hole at the top of the tank. Purpose of it is, for one, if you lose all control, it will eventually vent the tank down through that. It just takes a long time. But two is that static vent sets your fill time because it's where the flow is like choking. So as you're filling the tank, you're displacing air and then gaseous nitrous and siphoning liquid in. And the rate at which you can siphon liquid is set by the mass flow rate out of that static vent. So there are some hybrids that use like ridiculously tiny static vents. So they take like forever to fill. We've had to sit through like 30-minute fills at FAR from some hybrids that shall not be named. But for Mojave Sphinx and all of our rockets, we typically target a fill time under 2 minutes or under 1 minute, preferably. So Mojave Sphinx takes almost exactly 60 seconds by default. So essentially, once the pad setup is all done, you've hooked up your igniters and open your nitrous bottle. Like when it's time to launch it, we'll open the fill valve. It'll fill for about 1 minute, and then we close the fill valve, and then we have to immediately proceed to launching it.
Yeah, and that's I think Tim, the Wild Man, was on the mic when you guys flew at Airfest, and it was really funny to he was trying to fill the silence, and it was pretty having stood next to you guys saying, okay, it's full, give us a 5 count immediately, basically getting to hear from the outside on the PA of him just like being like, oh, okay, we're going 5. It was really funny. But yeah, I don't think people maybe just from watching videos realize that you're manually controlling all of this that's happening. So because you're firing the igniter even from the plane remote, right?
Yeah, I think eventually we'll work on a more integrated solution where one switch does like the valves and the igniter. But yes, all the switch flipping happens from our own controller versus a club GSE or something.
Right. And that's like you said, it calls for everything to be built in the guidebook for this. So this is almost could have been an email type podcast, but it's more of an already is a book type podcast. But so for any questions you have, I'm sure answers will be found in the guidebook. But feel free to leave them in the comments or send us an email at contact@aggpodcast.com, and we could maybe pass him along to Austin. I don't really want to sign you up for being in charge of fielding that duty, but I guess with your Discord community, it's kind of, you've already signed yourself up for that to some extent.
Yeah, Discord is the best place to get a hold of us. Please don't send an email. It won't be answered for 2 weeks to 2 months because I'm busy.
Perfect. All right. Okay, so Shane, any questions?
Yeah, like in solid propellants, we have like, barium nitrate and aluminum and magnesium and all these chemicals that create different effects in the burn of motors. What are there equivalents in liquid stuff? And if so, what are they?
Yeah, it's an interesting question because, like you say, in solids, you can change like the burning rate and things like that, which kind of makes solid propellants like very sensitive to like your exact proportions and all of that. Liquid motors are actually pretty interesting in that they're very insensitive to what you feed them. There's like broad classes of fuels that will generally all group around the same sort of like mixture ratio and performance metrics. For example, you've got like your hydrocarbons; those are like your diesels, your gasolines, your WD-40s, all the other kinds of oils, and then you've got alcohols, which are any kind of alcohol like isopropyl or ethanol or methanol or things like that, which they also share a lot in common with other organic solvents like ketones, which are like acetones. So as far as like additives go, it's hard to change the characteristics of the liquid fuel by adding anything because like unlike a solid, like the reason those kinds of things change solids is that you're changing the burn rate, and the burn rate like kind of dictates like the pressure you're getting, like based on your burn rate equation and your surface area and all of that. But with liquids, you're just straight feeding them a mass flow. So you got a fixed throat size. You're going to feed them a mass flow. You're going to get a pressure. The additives, if anything, additives will lower performance because they're introducing like solid particles that they don't have the same like combustion mechanisms and like characteristics that liquid fuel do. So you're moving away from your optimal like combustion there. There are additives like TIOS or PDMS, which are different chemicals that are supposed to like add a coating to the wall while it's combusting, reduce heat flux. In theory, it does something. In practice, I don't know that anybody has measured any like good enough data to say what exactly they do. And then beyond that, other additives would just be for fun. Like people kind of know by now our special colors that we do for our liquid fuels. So you've got a number of metal salts that can change the color of your flame. Like probably the most famous one is Garfield's Gorange, which is that is calcium chloride, and that burns a brilliant bright orange. That's what we flew at Airfest. Then we've also got like Mojave green, boric acid. We've got Cat Pun red, which is lithium chloride. We've got Meowpil, which is sodium iodide, I believe, and then Meowpil's potassium iodide, maybe. I don't know. There's a number of them. They're in the guidebook. Always open to trying more too.
Yeah, I was gonna say that's what Shane was asking there, I think, was how do you make it pretty colored? Yeah. But yeah, that's, if we could backtrack here for just a second, I think people are probably going to raise an eyebrow when you said WD-40. But you guys did fly WD-40 as if it was it just straight WD-40, or did you cut it with something?
It was in fact straight WD-40. There's a by now famous or maybe infamous picture of us pouring WD-40 straight from the can into the rocket. It was taken by Thomas Buska, I believe. I think it was Thomas and not Julian, but yeah, it's very well framed. It was not cut with anything. It burned just like diesel, which is to say we don't have like fantastic data measurements, so we just take what we can. It's just a hydrocarbon as far as I know.
Yeah, it's really interesting. Is there anything else kind of out of left field that you guys have used as fuel?
Across all of the rockets we've done, WD-40 is probably the funniest. It's also funny because the company was originally called the American Rocket Company when they produced it for coating the Atlas V's. or just Atlas back in the day. Besides
That's
WD-40, I'd say we did acetone one time because it was a 1Cat4 launch. We somehow forgot to bring like fuel, or maybe we didn't have enough fuel for multiple launches. And like I just went to some random college team who had like a jug of acetone, and I was like, "Can I have some?" And we just dumped it in the fuel tank. There was a time we also didn't have enough fuel for something else, and we like just collected all the random solvents for our have, just like random denatured alcohol and other crap. Uh, there was one time we put brush cleaner in 1Cat4 just because it was there. Somebody had it. So we just poured that in. It's a mixture of like nasty chemicals you probably shouldn't, handle normally. We've also wanted to try stuff like that. I mean, just if it's viscous enough to like, or inviscid enough to just like flow, and it burns it just like an atmosphere, we can use that as a fuel.
What?
Oh,
It's so crazy.
Oh, good.
I have one more fuel I want to mention. We used Jet A one time, and it's not that special in and of itself, except for the fact that it was drained out of an orbital launch vehicle before being put in the rocket. So
Oh, that's
Whoa.
awesome.
kind of fun.
That's cool. What's the fuel capacity of something like Mojave Sphinx?
The standard Mojave Sphinx uses almost exactly half a gallon of fuel. So it's really easy to know how much you're going to need.
Whoa. Okay. And what's sort of like the most cost effective? I'd imagine E85 is reasonably high up there, or just isopropyl alcohol.
Yeah, so people often wonder, like, why do we use the 85? It is because it is cheap. If you haven't noticed, we do burn a lot of fuel, and so for most people, I would say the cost of fuel will be negligible because half a gallon of anything doesn't cost that much. But we're going through so much of this stuff that it actually does start to add up. So E85 for us is like, here in California, I don't know, like $3.50 a gallon, typically, something like that. We've used E98, but that just costs more because you got to get it from a specialized place. Isopropyl costs like $25 a gallon, so that's just a lot more than we care to pay. But yeah, it can vary a little bit.
You got to just come out by me and Shane out here near Ontario. There's a place over here that's like $2.75 a gallon. And I'm like, dang, maybe my car needs an E85 too.
Wow.
But yeah, I guess so. Considering the A motor and the fuel, what do you have roughly a cost per flight just of expendables like that?
Yeah, for Mojave Sphinx, the biggest cost is nitrous. It takes about 10 pounds to fill it. That's including venting losses. There's a place here that you can get for like $5.25 a gallon per pound. So when you add up that cost plus the fuel plus the igniter and the E-matches you'd use, you're looking at around $60 per launch if you're using the 85.
I mean, for full L impulse, that is a pretty solid deal.
That's a deal. Yeah.
So I guess one thing I saw a lot of in the questions, which we'll get to in here in a moment, is what do you think, if you could estimate the overall cost of just like starting with nothing to build a Mojave Sphinx?
Well, I don't have to estimate because it's in the guidebook. Of course, inflation and possibly tariffs have impacted that these days. But the cost for the rocket is somewhere, I think, under $1,500. And I'm saying I think because, like I said, it's been over a year since we published it, and I don't know, what the costs look like these days. But I would say if you're starting from nothing, maybe plan on $1,500, assuming you're fabricating the machine parts yourself, like machining them. If you don't have access to those machines, then maybe tack on a few hundred more dollars to get those from a service. And if you have nothing, I'm assuming that includes GSE. So GSE costs another $400 or $500. All in all, if you budget $2,000, you should be able to make everything you need, including consumables for 3 launches.
And I mean, you guys have flown it. Is the website currently up to date? 26 flights and over 30 static tests?
Yeah, so that's actually not current with the latest ones we just did. So I'm actually pulling up here our latest stats. But yeah, we just did like 3 launches on Saturday. So we are now up to, for Mojave Sphinx specifically, geez, we just did launch up to through launch 29, 30, 31, and then static firing. I don't know. I think the static firings are up to date. Oh, yeah, whatever that said, 29,
I think it says 32 at the moment. So
32.
I guess
so
if
32 static fires.
any more proof is needed that it's a pretty reusable investment. I don't know what better info you could have than that. How much is the motor itself like largely original?
You mean like as far as the design goes?
Yeah, like the internal components and everything. There's some things that aren't expendable. Do they wear down over time or?
Oh yeah, I would say the parts themselves don't really wear down. Like the machine components are pretty much good indefinitely as long as you don't like abuse and like crash them or something. There is some maintenance stuff. There's a maintenance schedule in the book, in I think section 2 or something, where you'll need to change out O-rings occasionally, like changing out shock cord, a few other things that are in there, mostly like O-ring type things. But as long as you stick within the bounds of what you're supposed to do with it, then it's like completely reusable.
Awesome. Well, as long as you don't wreck it, like you said.
Yeah. Speaking of wrecking, so in the development of Mojave Sphinx, did you guys have any catastrophic issues or any crazy things that happened while developing it?
We ran into a number of issues. I wouldn't say anything that was like catastrophic. The only thing I'd call catastrophic would be like an explosion of the tank, which we've never had. The only time we ever had that was our like very first HalfCat tests a long time ago. And we did have a number of failures along the way. Serial number 1 has like 19 launches and 20 static fires, so it's got quite a bit of history to it. We burned through several thrust chambers in developing that. We originally had like all aluminum, and the throat would sometimes melt, so we swapped that out for a copper throat. We had some gasket failures, so we like added steps to like check the torque on the chamber. We had some leaks, some clogging issues when we put too much boric acid and just like straight up filled the thing with like sand. That was a rather trying time for HalfCat Rocketry. We had some recovery failures just due to either our own laziness or like wearing stuff out and not really checking on it. We actually just had this past Saturday, we had an oopsie that was entirely human failure, which is why you should use checklists, kids. We forgot to attach the quick link to the recovery bulkhead on SN4, so it just straight up wasn't attached when we launched it.
Classic.
I've done that.
The whole propulsion system came down. However, miraculously, the tank actually survived. Like everything was smashed. Like almost all the other parts were just like smashed, but the tank was like fine. I think we're going to be able to reuse it. So serial number 4 lives to fly another day. And our ComSpec transmitter was still transmitting from a foot underground, which is shocking.
Wow.
That's impressive.
That's good info to have. So you and Charles started this all in college, correct? And I'm just to add a little bit of field of credibility in case somebody out there is still doubting as to why they should listen to you after, all of this experience has been covered. But you started HalfCat in college, and could you quickly touch on what you and Charles do for a living now? Yeah,
we're both professional propulsion engineers. Charles previously worked at ABL, the launch company, and now works at Impulse Space on Helios. I work at Anduril. I previously worked at Virgin Orbit and Inversion Space. So we do work on like large propulsion systems. We both worked on large rocket engines. So yeah, I guess you could say we do know what we're talking about a little bit.
I just wanted to have that credibility cleared there in case there's anyone casting doubt at this point.
Just top you.
Does anyone else have anything else, or should we move on to the Patreon questions? We got a couple.
I've got one question real quick. With regards to the filling time, Is there any like cap on that for the Tripoli rules, or is it like, it could take you, if you want to fill up for 30 or 60 minutes, you can do that?
There's no cap from Tripoli, but I think any RSO with common sense is going to be like, somebody shows them as like, I have an hour filled. They're going to be like,
Yeah.
you're not flying.
I was going to say,
field, sorry.
Like they're
right.
tie up the pads and all that.
Yeah,
that's
it's more like, it's from a safety perspective of like, okay, there's nothing necessarily wrong with it. Like you can do it, but for practical reasons, people aren't going to do it.
Okay. That makes sense.
Yeah, it makes me wonder, Taylor, if we're going to start seeing like the resurgence of the hybrid pads. There's going to be liquid pads because that was what they ran into with the hybrid stuff, was all the additional GSE and setup time. They ended up like a lot of launch sites were like, here's your separate little area. Just tell us when you're ready.
And it honestly worked really well. So I wouldn't be surprised if as it gained popularity, to see something like that.
Okay, well, that actually is a pretty solid segue into the first question we have on the Rocket Vlogs Patreon. This is from the Rocket Vlogs Patreon. Do remember, you can also support us on the Anti-Gravity Group Patreon, which will always be linked in the description of the podcast. Rod Thomas asks, I don't expect to get into liquid motors, as working with flammable liquids can be dangerous. There's a lot of stuff we handle with solids that are also dangerous, but we'll just stray away from that topic for a second. I'm wondering if fields working with flammable liquids will be required to do their prep work at a specified distance from other Rocketeers. And Austin, like you were saying earlier, other than nitrous and, general liquid chemical concerns, it's a fairly inert process to set the rocket up. So at least in my perspective, I don't see anything immediately that would lead me to think that there would be a separate designated setup area for liquid stuff. But what are your thoughts on that?
Yeah, like you said, kind of like we were talking about earlier, there isn't any big hazard there. I'll argue till I'm blue in the face that solids are just much more dangerous because of their potential to, catch fire and explode. But yeah, when you're working with the liquid fuels, first of all, a gas station is actually way more dangerous because of those like flammable gas vapors. The liquid fuel is very tame, very benign. The ones that are allowed, like your alcohols, or even like a diesel fuel. So especially like, you set the rocket up, you pour the fuel in there and then you cap it off and it's sealed in there. It's not going anywhere. So there's really no danger there. And if a club was so inclined, if they really wanted to limit it, which I don't think they do, but if they really needed to, you could say, okay, isopropyl alcohol only or pure ethanol only. And then it's like, okay, it's a giant jug of hand sanitizer or cleaning fluid, right? Like people wouldn't consider that dangerous. So they don't need to be put away while they're like fueling or any of that. Generally just do it outside and maybe over the grass or something. So a spill doesn't just like, go onto like somebody's stuff.
Yeah, I've been at FAR a lot of times with you guys prepping right next to us and never felt any sort of a threat. In fact, we've talked about this on the podcast, but I feel a lot more threatened by the people that set up ejection charges and then feel the need to turn their electronics on to test continuity while the rocket's sitting on the table 10 feet from me. But again, another conversation for a different time. Zero G Prince says, how similar in technology are your liquid motors to hybrid motors? And do you think that there will ever be a commercial liquid motor like there are hybrids? Presumably commercially certified.
There's a lot of crossover with hybrids. The nitrous oxide operations are all really the same. And this is what we originally were shooting for in making our first liquids, was like, can we kind of match the operational simplicity of hybrids? There's a lot of crossover in like what the propellant tank looks like. It's bulkheads and a tank casing. You do have the addition of like the valves and a separate chamber. Although monotubes are possible, I will say that people have been doing them. So like functionally, they pretty much operate the same as hybrids. Like if you've done hybrids, and especially EX hybrids, these HalfCat style liquids are like going to be very, very familiar to you. And then as far as like a commercial liquid, I think it's possible that we'll see one in the future. If I'm not mistaken, I think there's maybe some NFPA rules that need to be adjusted. That could potentially be coming in the next couple of years if these things take off. No pun intended. So it'll be a matter of like the kind of thing that people would both want to buy and want to use, and is like easy enough for them to do that. And I'll again hint at something that we're working on right now to hopefully announce in the next couple months. That'll be even easier and maybe better, and could potentially lead towards that sort of thing in the future.
Hey, we love a good podcast exclusive pseudo announcement. So, Colin Brum has one in a sort of a similar vein. It says, is it a good idea to learn hybrids first, or are they different enough that it's unnecessary? I would almost lean towards hybrids being more complicated as a starting point, but I don't really know what I'm talking about.
You could go either way. If you have access to hybrids, maybe your club has a GSE or some hardware, or someone else can like mentor you, it can be a good introduction, especially if it's your only way to get into nitrous-based stuff. You'll learn some of the operational things. If you're like ready to take on like a big liquid project, like you're ready to start Mojave Sphinx, you don't have to go through hybrids, like especially at this point. So it's kind of up to the individual person, but it's by no means a requirement, but can be helpful if you have the opportunity to get your hands on some like contrail hybrids.
We've been trying to get Matt to buy, is it a Hypertech setup that's on eBay, Taylor? Or is it a contrail? You're muted.
Ratworks.
Oh, that's right. Wow. Rogue. Every time I hear it, I forget that they existed for a minute there, but that's a classic. Okay. Robert, actually in a similar vein, asks, is there any additional equipment / controls that a Rocketry club might be expected to provide in support of liquid fuel flyers? But like you suggested, if they're following your guidebook, it's pretty self-sufficient, but does anything come to mind?
The club could provide hybrid GSE like you see for like existing hybrids. I would say the club doesn't necessarily have to bring anything of their own, because the ground systems are pretty much easy enough for anyone to fabricate. It's just maybe a good idea to like have a club set, makes it a little bit easier for everyone. Especially if they want to like tie it into their own control scheme. So
cool. And finally, we've got one from Liam, and he asks, is there any software to simulate liquid motors? And we'll just stop it there. I know the answer, but I'd rather have you answer it.
Yeah. Okay. Just a real quick history lesson. When we started liquid rockets, there was absolutely nothing. There was very little, very few resources out there to build liquid rockets, and there's especially nothing to simulate them. Like RPA, rocket propulsion analysis, is not really relevant. That's how you design like a thrust chamber and stuff. There's really nothing out there. So basically, I went and made one. We call it HalfCat Sim. I made this Excel program over the course of the past few years. And that's how you design a HalfCat style liquid motor. It does the full simulation of the thing, gives you a thrust curve and all of that. So yes, there is software. It is available at halfcatrocketry.com/halfcatsim. It is free as well. It's best if you have Excel. You can use in Google Sheets. Some stuff breaks, so I recommend using Excel. But yeah, it's there. That's how you do it.
Yeah, that's awesome. I just figured that would be a good way to finalize a little bit of a plug there, since that's the end of the questions. So before we get out of here, is there anything else imperative you want to suggest to people who are looking to get into liquids? And otherwise, feel free to plug your website away. Tell the people where to go.
Yeah, I mean, best advice I can give is grab a couple friends, take a look at Mojave Sphinx, start talking to your local Tripoli club, and see what they can do to support liquids in the future. Most important thing is just being safe and being reasonable with it. So I don't know, have fun, learn some new skills along the way, like machine skills, and just have fun, I guess.
That's what we're all here for, right?
Yeah.
Well, thank you so much for being here, Austin. This is really enlightening. I'm still pretty well in the dark, but it does shed a little bit more confidence in that it is something that generally I could figure out if I were to get into it. And I think it's going to help a lot to put people's sort of safety concerns to the side because, as with anything new, things can be scary when it's unknown. So I had the privilege of seeing you and Charles fly enough times that I don't really have any concerns about the way you guys are operating. And since you quite literally wrote the book on how to do it, I think it's a phenomenal starting point for anybody who's looking to venture down this. I'm super excited to start seeing just people flying bipropellant liquids at Tripoli launches. It's going to be awesome.
Yeah. I just want to say too, I think it's really awesome that you guys went, open source here, fully transparent, putting all the details out there for people to take and eat up. So I think that's really awesome you guys went that route.
And on that note, I think that is going.
We didn't have one.
Yeah. Sorry, Braden.
I was almost got away with not having to edit this episode.
There's a little bit of lag.
I ruined it.
Yeah. No worries.
Oh, thank you so much for listening to another episode of the Anti-Gravity Group podcast. My name is Braden Carlson. You can find me right here on YouTube at Rocket Vlogs. And you can find me on Instagram, Rocket Vlogs Official, and Facebook at Rocket Vlogs. Imagine that.
My name's Taylor. You can find me on YouTube at the Rocket Channel.
My name's Shane. You can find me on YouTube at Postart Propulsions or on Instagram at Shane Harris Photo.
My name's Matthew Myers. You can only find me here and nowhere else.
And at Garmin.
I guess at Garmin too.
Austin, thank you so much for joining us, everybody. One more time, that is HalfCatRocketry.com. If you want to do liquid stuff, there is a literally almost hand-holding step guide for doing it. So please proceed safely and take advice from a lot of people that have done it before, or a couple people that have done it a lot before is what I was trying to say there. It's the end of the episode, dude. I'm just butchering.
No, you're doing great.
Everything. We are the Anti-Gravity Group. This is the Anti-Gravity Group podcast, and we will see you all next time.
We might just hear from Nigel the Rocket Cat. Load up the professional masterpiece, you can bet on that. A launch and a chat with them is guaranteed to be a blast. It's the Anti-Gravity Group podcast. Ooh.